Welcome back, nerds. I am recording again just so I can get it back on YouTube. We got a bunch of people that were asking for me to bring it back. So here he is. We're bringing it back. Today's lesson is called Solving Quadratics by Square Roots and CTS. And by the way, CTS means completing the square. Whoa, what? Okay. Anyway, solving quadratics by square roots and completing the square. We'll start by solving by square roots, which means basically just get x by itself. Sad mep, get x alone. So you're looking at this first question. I got x stuck inside a set of parentheses that has an exponent on it. How am I going to get that x alone? What do I need to do first? Yeah. I could square x minus 4, but I'd be actually creating more work for myself. Just do sad mep. Start getting x alone. I'm a loon. Square root both sides. Yes. So we are going to take the square root of both sides because square roots cancel squares. Like that. But. Tell me, what number squared gets me 4? 2 is one of the answers. And negative 2. Remember, you should have learned this in Algebra 1. When you cancel a square with a square root, it creates a plus or minus on the other side of the equation. Like that. You have to remember that. Because this is a quadratic, and quadratics are supposed to have 2 solutions. So we take the square root of that 9, and what we'll have is plus or minus 3. Like that. And then we're just adding 4 to both sides. Notice I did not add it to the 3. Because what that gives us is x equals 4 plus or minus 3. Literally, x is 4 plus 3 and x is 4 minus 3. So x is 7 and x is 1. If you are concerned that you're going to accidentally add this 4 to this 3 and you're going to say plus or minus 7, and you know, this is an individual basis. If you're concerned that you might accidentally do that, then before you add 4 to both sides, write this as 2 different equations. And then add 4 to both sides. So that's up to you. That's a you thing. You have to make that call. Will you remember that the 4 goes in front of this because this is 2 different numbers? If you will, then by all means just go to here and then write your 2 answers, 4 plus 3 and 4 minus 3. But if you're concerned, I don't know if I'll remember that, fine. Write it as x minus 4 is positive 3, x minus 4 is negative 3, and then solve them independent of one another. It doesn't matter. Either way, you get those 2 answers. Comfortable with those 2 answers and how we get them? Yeah? Cool. You know what I just gave you? I just gave you an efficient way of going from vertex form to intercept form without graphing. This quadratic, if you were going to write it out, would be f of x equals x minus 4 squared minus 9. And we just found out that it crosses the x-axis at 1 and 7. Which means, really? This is the same quadratic. So we now have an efficient way of moving between vertex form and intercept form without graphing. Now we didn't need to get to here. This is bonus content. In fact, first period, I didn't even say that to them. But I just wanted you to know that that's what this could be used for. It can be used to convert between forms. without graphing. So let's keep it up. Let's just make the question slightly more challenging. SADMAP, getting x by itself. What's the first thing we're going to do? Lots of people should be able to answer this question. Subtract 1 from both sides. Let's subtract 1 from both sides. Max, this is where, what do you want to do next? Multiply by 2 on both sides. This is where you want to do that. Now we multiply both sides by 2. Because 2 halves is 1. That'll cancel that fraction, leaving us with x minus 4 squared equals 12. And now this question is just like the first one. Take the square root of both sides. The only difference is in that first one, 9 was a perfect square, but in this one, 12 is not. So since 12 is not a perfect square, we have to split it. Bless you. So what two numbers? Well, there's only one perfect square that'll go into 12. What is it? 4. And 4 will go in 3 times. I'm just reminding you that I used to teach my students to identify the thing that was stuck. I know in my final answer there will be a 3 inside this square root bar, but I can take the square root of this 4 and bring it to the front of the radical. The square root of that 4 is 2. 3 is stuck. There's only one thing left to do. And that's, add 4 to both sides. Now check this out. They are not like terms. So I cannot add 4 to this by accident. The only thing I can do is put it right here in the front. My answers are x equals 4 plus or 4 minus 2 root 3. Unfortunately, we wouldn't want to convert this to intercept form because its intercepts are ugly. Remember when I told you about graphing? Solving by graphing is only useful when your x-intercepts are pretty numbers. These are not pretty numbers. So we would never try to solve this by graphing. This is in vertex form. What is its axis of symmetry? X equals 4, right? X equals 4 because the axis of symmetry always cuts a graph in half, correct? Great. Look at the answers. There's the 4. There's the axis of symmetry. When you solve by square roots, you're always going to be told where the axis of symmetry is and how far to the right and how far to the left your solutions are. This one, the axis of symmetry was 4. A solution was 3 to the right of 4 and 3 to the left of 4. And if I were to graph these two things, the intersection point would be 2 root 3 to the right of 4 and 2 root 3 to the left of 4. It's pretty neat, realizing that this is the axis of symmetry. I had an Algebra 2 regular student tell me that. Actually, he asked, and I already had a degree and had been teaching for a very long time. And this kid goes, wait a minute, does that mean x equals 4 is the axis of symmetry because it's halfway between the two answers? And I was like, yeah, that's exactly what that means. It was an incredible result because I'd never really thought about it, but that's exactly what that means. It's really neat. And from there on out, I started using that skill, that realization, that deep knowledge as an extra credit question because it's really easy. It's a very easy thing to answer if you understand the quadratic. Anyway, let's make the question slightly more complex. What's the first thing I'm going to do? Anyway, some people said subtract 2 from both sides. Let's subtract 2 from both sides. Last time we multiplied both sides by 2. What are we going to multiply by now? -2. That is going to leave me with x plus 3 squared on the left. But on the right, I have -8. Because we have a negative over there, what kind of answers are we going to end up with? Imaginary, more specifically complex. Did anybody catch that I said, let's do a more complex question when I slid the paper up? That was on purpose. I'm proud of myself. Anyway, take the square root of both sides. We have to break -8. What perfect square goes into 8? 4 does. So what we're going to say is we're going to break our -8 into a -4. Remember I told you from now on we treat -1 as a perfect square. So we'll say -4 times 2, and that's going to give us this x plus 3. This will be our stuck number. That 2 is not getting out of that radical. Forever in jail. But I can take the square root of -4 out. If the square root of 4 is 2, then what is the square root of -4? Lots of voices. 2i. Awesome, awesome, awesome. So we have x plus 3 equals plus or minus 2i root 2. And the last thing that you have to do is subtract 3 from both sides. And these aren't like terms, so clearly you can't combine them. And your answers are, wrong color pen, x equals -3 plus or minus 2i root 2. Not only is this complex, it's also irrational. So complex and irrational, like my wife. Yeah, buddy. You don't have to tell her I said it. She can watch the video. That's right, woman. I said you're complex and irrational. There you go. See? I repeated it. All right. No, she doesn't watch these. She has to deal with me on the regular. You think she's trying to like have instant replays of me? Okay. So that is why I taught us the complex numbers before we finished solving by whatever methods. Psst. 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 You don't know it, but I'm making another joke. Because I don't ever write perfect square trinomial. I always write PST. Psst. It's not really a funny joke, but not only did I need your attention, but it also fits the bill. So anyway, we did 2 methods for solving quadratics before we did complex numbers. We did solving by graphing, which is only useful if your answers are pretty or if your graph even crosses the x-axis. And then we did solving by factoring, which is only useful if your answers are pretty and if your graph actually crosses the x-axis. Then we learned about complex numbers. And the reason why is because not all quadratics cross the x-axis, which means we need a way of solving quadratics that may or may not involve irrational numbers and or complex numbers. Now we can do that. So you just saw that it's possible to get irrational numbers. It's also possible to get complex numbers when solving by square roots. But that is if your quadratic is already in vertex form. What if it's not in vertex form is the question. The answer is you convert to vertex form. That's going to require us to have knowledge of what a perfect square trinomial is. A perfect square trinomial is any trinomial, that means something that's made of 3 parts held together with pluses and minuses, that can be factored into a single squared factor. For example, this is a perfect square trinomial. What two numbers multiply to 9 that add to 6? 3 and 3. So instead of writing x plus 3 times x plus 3, we could do that. Literally x plus 3 times itself. This is a perfect square trinomial, a pst. So what we're going to do here, and in fact, I'm going to change this a little bit. Let's do, let's just pretend this just said plus, and then we'll do below it, we'll do the minus. So we'll do them both here. Okay. A plus b quantity squared is a plus b times a plus b. If you go through the distribution process, we have a times a times b times a, but keep it alphabetical, b times b. These two things in the middle are the same. A squared plus 2ab plus b squared. Yes, sir. It'll get a very similar result. Only one thing will be different. So let's go ahead and do it. Oh, I didn't mean to be writing in blue right now. I was trying to, well, whatever. Too late. It's already done. Can't take it back now. Anyway, a times a gets me a squared. Now, a times negative b gets me negative ab. And then again, negative b times a, keep your answers alphabetic, is negative ab. But negative b times negative b is still going to be plus b squared. The two things in the middle are the same kind of term. We can combine those like terms and get a squared minus 2ab plus b squared. So hopefully you can see that only one thing changed. This symbol. That's the only difference. And by the way, a and b could be numbers, they could be letters, they could be numbers and letters, they could be entire equations. They're just structures, objects like triangles. All perfect square trinomials are written in either of these two formats. Manipulating a trinomial so that it contains a perfect square trinomial is called completing the square, because you're literally trying to make it something squared. So it's called completing the square. Completing the square is the way that we convert standard form to vertex form without graphing. So I had you doing it with graphing. So when I was doing those for you in those notes, we were graphing our standard form, and then once we found our vertex, we stole the a value and we wrote it in vertex form. But that's only if you're going to go through the graphing process. You don't have to go through graphing. Just like you saw me turn vertex form into intercept form without graphing on the front, we can use completing the square to turn standard form into vertex form without graphing. It involves finding what I like to call a magic C value. Yes? On the front, we converted this vertex form to intercept form without graphing, because we were able to see its solutions. And completing the square is the way that we can turn standard form into vertex form without graphing. In order to do that, though, you need to have the skills of being able to find, again, what I like to call magic C. This C value is a very specific number. Now, I'm not a big fan of people just following patterns without knowing why they work. I don't like that. So I'm going to show you an example on this piece of paper that you don't need to write down, but I'm showing you why we know this pattern works. Okay? X, somebody give me a one-digit number. I heard 3 a few times. Positive or negative? Negative. Sounds good to me. All right. If we do x minus 3 times x minus 3, I'm just going to hope that you trust me on this one because I'm trying to save a little bit of time and space. You're going to get x squared minus 6x plus 9. So we know that x squared minus 6x plus 9 is a perfect square trinomial, right? It's in this format. Right? Great. Let's say we didn't have the plus 9 and our job was to find it. And they go, we're trying to track down this number that will make this thing a perfect square trinomial. The only way it's a perfect square trinomial is if that business in the middle, if negative 6x is negative 2ab. That's the only way that could work out. But remember, if it's a perfect square trinomial, it's in this format already. That means a is x. All you have to do to get b by itself then is divide both sides by negative 2x. And what you'll get here is that b must have been the number 3. So the number at the end is b squared, must be 3 squared, which is 9. I was showing you why we're able to take a shortcut in just a moment. Before I do that, though, I need to ask, do you have any questions for me? Really? You had question face. What's that? Yes, you looked very confused. Okay. Are you all comfortable with what I just did? And you believe why it works because we know that this had to be we were trying to force this scenario to occur. Meaning this middle term had to be negative 2ab. And we can already see what a is. Our job was just to figure out what b had to be in order to pull that off. Yes? Nope, works all the time. It's not always pretty. Sometimes you're going to have fractions, but it always works. Every single quadratic can be written in vertex form. They're just not always pretty, but it always works. The good news is I'm not going to ask you to do it with fractions because, I could, but the problem is if you miss a question on a test, I won't know, was it because of the fractions or is it because you didn't have the skill? You know what I mean? So I won't throw the fractions in there because I don't want you to, I don't want to double skill test you, Every single question I put on a test is looking for a single skill. Okay, so here's how the process shorthands. Instead of going through all of that, realize what we did was we said this middle term must have been 2ab, correct? It had to be. So what we're going to do is we're going to take that middle term and we're going to cut it in half. We're trying to get rid of this number. So we cut both sides in half. I don't need the x because it's always going to be x. So I can ignore the x part. Look at that. The x part doesn't matter because it's always going to be x. So all I had to do was legitimately cut the number in half. So we cut our number in half. And then remember that number at the end is b squared. So you take this number and you square it. That is your magic c value. our perfect square trinomial is completed, see, completing the squared. It's completed when we say x squared minus 4x plus 4. The last set of instructions is to factor this. What two numbers multiply to 4 that add to negative 4? Negative 2 and negative 2. Check this out. Every time. Every time. This number belongs in here. So you might be wondering then, what was the purpose of that number? You'll find out. But for now, I need to know, do you have the ability to find this number and then factor? That's what I need to know. Are there questions on that process? Allie, you have question 4 head. You sure? So you just crinkle and you just make a pack of hot dogs up there for fun? Yeah. Okay, gotcha. All right. Why do we divide by 2 again? Because the middle thing, in order for it to be a perfect square trinomial, had to be double AB. And since A is always going to be X for us, we don't even have to worry about the X. So what that means is that thing in the middle is literally double your B value. You're always dividing by 2 to figure out what B is, because then you have to square B to get this number at the end. Divide by 2 and square, yeah. That's literally what you would do here too, right? If I say, hey, cut that in half, because I want to know what B is. So cut it in half. We already know A is X, whatever. You cut this number in half, you're going to get negative 3. Square it, positive 9. Works every time. But why we're doing it matters. I'm glad you asked. Let's do it again. Skirt. We're going to take that number in the middle. This time it's a 12. We know in order for this to be a perfect square trinomial, that must have been 2AB, but A is X. We already have the X, so what we know is that 12 is 2B. So cut it in half to figure out what B is. B is 6. And this term at the end is supposed to be AB squared. Not AB squared. It's supposed to be an example of B squared. Stupid English. Our magic C value then is 36. And we need to be able to find that number. It's the only number that could have gone right there that would have made this a perfect square trinomial. X squared plus 12x plus that 36 has completed our perfect square trinomial. We've completed that square. And the two numbers that multiply to 36 that add to 12 are this number and this number again, 6 and 6. So x plus 6 quantity squared, and like I said before, every time it goes right there. What do you think about that? Do you have any questions for me about how we track down magic C? Or why we're doing what we're doing? How about the factoring process? Everything makes perfectly good sense? Okay. Then let's take this newfound skill we have right now and use it. This is a quadratic that factors real nicely. It has two nice x-intercepts. The x-intercepts are 1 and 5. You don't have to know that, but I could change it into intercept form just by factoring it. But what about its vertex form is the question. What about its vertex form? You see, this is not a perfect square, this 5, which means this 5 right here cannot be my B squared. It can't be that magic C value, can it? Our job then is to figure out what that magic C value is. We have a problem though. When I figure out what that magic C value is, I will have changed my equation. And I'm not allowed to change the equation. So let's track down that magic C value real quick. Don't move ahead without me though, please. Let's track it down. Let's take our middle term. And since we know it is 2ab, and we already know a is x, so we know this is 2b, we'll cut it in half to get negative 2. Magic C value, which is b squared, is negative 2 quantity squared. So I'm going to put a plus 4 right there. And I'll write it in red so that way we can see that it's new. Here we have an issue though. Yeah, I completed the square. In fact, I don't know if you caught it, but it's literally this example here. I completed the square. I know this factors. This is a perfect square trinomial. But I just changed my equation. It's supposed to say plus 5. This one now says plus 9. It's been altered. I'm not allowed to do that. So how do I make sure that I didn't actually change the equation? I'm just manipulating the way it looks. It can't say plus 9. It's supposed to say plus 5. So what would I have to do so that it did say plus 5, Jared? Oh, and I would have to subtract 4, wouldn't I? Can we agree that together these two red things equal 0? Yes? So can we agree that all I did was add the number 0? Yes or no? And can we agree that adding 0 doesn't change anything? Okay. So then I didn't change anything, but in a very specific way. I did it in a way that would allow me to factor a piece of my quadratic, because that is a perfect square trinomial. And the two numbers that multiply to 4 that add to negative 4 are the same two numbers they were a moment ago, negative 2 and negative 2. Oh, by the way, 5 minus 4 is 1. And now it's in vertex form. That's why we need to be able to figure out what that C value is. Because it's not enough just to be able to get to the squared parentheses. You need to know how to do a very specific nothing to your equation to get it to vertex form. Do you remember how we were finding the vertex of a standard form equation before? When we were having to graph them? How do you do it? X equals negative b over 2a. So negative b is negative negative 4. So 4 over 2 times 1, 2. 4 over 2 is 2, right? So we know x equals 2 is the x value of our vertex. Hey, look. X equals 2 makes the inside equal 0. And if you plug 2 in, you get 4 minus 8 plus 5. That's 9 minus 8, which is 1. Hey, look. The y value of a vertex is 1. This is how you go from standard form to vertex form without graphing. Wouldn't that neat? I mean, I think it's pretty neat. I think we're going to call it there because that's as far as I got with period 1. And I don't want to have to ask period 1 to go faster. But you can do the first half of your homework now. You can do 6 of the 12 questions. And tomorrow, we'll take this up a couple notches. Thanks, folks.